So Pythagorean theorem is works with right triangles only. So if we're looking at a different triangle that's not a right triangle, we want to make sure that it's a right triangle. So it only works with right triangles. And that the Pythagorean theorem is one of the most popular, I guess, um, formulas to be used. So it states that a squared plus b squared equals c squared. And this with a right triangle, when we look at, so our first example, let's say that it's 5 feet going up. Our height of our triangle is 5 feet. And we're going to go out a little bit and a little bit longer and then come down with our triangle. So this right angle means that it's a right triangle. So we're going to say that it's 5 feet up, 12 feet wide, and we have this long side that we're going to need to find that distance. So that we call C. And C, this C right here is always the longest side. So that right there, what we have a special name for it because it is the longest side, is called the hypotenuse. Hypotenuse. And that hypotenuse, let's put a little star over here, it is the longest side. The longest side. And it can always be found by going directly across from the right angle. So if C is the hypotenuse, and we have these other two that we have, and they call them the legs, or we call them the legs. So we've got one leg here and one leg over here on the 12 and the 5. And it doesn't matter which one's which, because if we rotate it a little bit, it might be the other one. So the other two labels we have for those are A and B. And since A is up here, or I usually do A first and then B, but it doesn't matter, you can switch them around, that would be fine also. Now, when we solve for the Pythagorean theorem, we kind of have some steps that we show by solving. So the first thing we do is write the formula down. Second thing we do is substitute. Third, we solve. And that one's pretty much the longest of the steps. And then the fourth is the answer. And the last, so I like kind of having 5 things for my 5 fingers, is the label. And this one is the forgotten one because a lot of times we get to the answer and just want to be done with it, but we have to have that label. So formula is, it's a right triangle, so I'm going to write down my formula for the Pythagorean theorem. A squared plus b squared equals c squared. I will substitute, so I said a is 5, so I'll substitute 5 in for a squared. B is 12 squared, and c is what we're solving for. So now to solve this, I just take 5 squared, which would be 25. So I'm doing a little bit of order of operations. 12 squared is 144. I have to do squared first before I add them. Now in solving, we're just going to bring everything else down. 25 plus 144 is 169 equals c squared. Bring that equals c squared down. Now to undo that squared, we've learned that it's the square root to cancel that out. Sort of like undoing multiplication with division in solving equations. We have a new process to cancel out a squared. So if you do one side, if we square rooted one side, we also have to square root the other side. Now, technically in mathematics, this has a plus minus in front of it because you could have a positive one that works and a negative one that works. But for this problem, because it's a triangle up here, it only is going to be using the positive one. So we're going to, the square root of 169 is 13, and that equals c. Not c squared, because remember the squareds got canceled out, by the square rooting of both sides. So the side C is 13, which is our answer, but now we need a label, so I'll look back up here and find that it is feet. So I'll put 13 feet as my answer and circle it, and there is that steps. The formula, substitute, solve. Remember, undo the square root or squared with the square root on, and remember you have to do it to both sides, and then answer and label. For another example, example number 2, we use that same steps, but this one's a little bit different, so our triangle is going to go a little bit different. But we're going to be given a right triangle. So now I see that this other side over here is my hypotenuse, that longest side of any right triangle. So I'm going to label that C. And then we have an 8 centimeters by 15 centimeters. So to solve this, I'm going to first, number 1 is formula. It's a right triangle, so I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. And then I'm going to substitute them in. So 8 is a, I guess, and 15 is b. So 8 squared plus b is 15 squared equals c squared. And now I can simplify this and solve. So 8 times 8 is 64, and 15 times 15, you could do a little sideline math if you need to, but I've used this one quite a bit in my Pythagorean theorem, so I know it's 225 equals c squared. Now I'll add those together, so I will get 289 equals c squared. And with that one, we're going to cancel out that squared with a square root. If you do it to one side, you have to do it to the other side. And it is a plus and minus there, but because this is a right triangle, I only use the positive one. So I'm going to bring down my c equals, and I don't remember this one as much, so I'm going to type this one into my calculator. This one might be on a calculator day or something. So, and it is 17 times 17. And actually, if I thought about it, I could have thought, hey, what numbers in the ones place would give me a 9? Well, I probably would have thought about 13 times 13, but that would make it only in 169. But 17 times 17 will give me a 9 in the ones place. So that's the one I would probably test if it wasn't on a calculator day. So that would be 17 would be my answer. But before I circle it, I want to look for my labels. So centimeters would be 17 centimeters would be my distance of my hypotenuse. Now example number 3. And this one's a little bit trickier in our picture of our right triangle. So this is not as usually as where we've gotten our numbers usually, or how they look. So if we have 0.03 inches here and 0.4 inches here. Now, normally my C was on the top, but I'm looking for that hypotenuse right across from the right angle. So my hypotenuse now is down here on the bottom, but I can still use my Pythagorean theorem because it is a right triangle. A squared plus b squared equals c squared. So formula. Then substitute. A and b don't matter which one's which, so I will start with the 0.4 as the A and 0.3 as the B. So 0.4 squared plus 0.3 squared equals, I missed my squared up there, C squared. Now I'm going to multiply those, square those, multiply those up. 0.4 times 0.4 is 16, and it's one place value times one place value is two place values. So it's 0.16 plus 3.3 times 0.3 would be 9, and then one place value times one place value is two place values. So I 0.09, and that equals c squared. Now I can still add those together, so 0.16 plus 0.09 would be 0.25, or 25 hundredths, equals c squared. And to cancel out that square root, I'm going to take the squared, I'm going to take the square root of one side to cancel that squared out. If I do it to one side, I have to do it to the other on the equations. So now we're left with c equals, and let's see, 25. Ooh, that would be 5 times 5 is 25. And what number times, or place value times itself is 2. So this is a tricky one, and it's only one place value. So 0.5 times 0.5 will give me two place values in that 25. So I'm thinking about this. Oh, my last one was the label. So I had inches right here, so I 0.5 inches for my length of my C. And remember, we want to do formula, substitute, solve, answer, and label, the 5 steps to solving Pythagorean theorem.